Fortunately for us, this is the only case we're going to use it because we want to use it to factor things. So we can only use it when you're dividing by, we call this a linear factor, which means it's just an x, okay? So you can't use it like if you're dividing by x squared or x cubed, meaning the divisor has to have an x in it. Just be aware, like let's say you have something like this. Does that look exactly like that? It does not, but what we could do is we could write it, we could divide both things by 2, and we would write it as x plus 1/2 instead. Okay, so we can use it to divide things that look like this as long as the degree is 1, but we would want to switch it so there's just an x in front. Did you guys see how I did that? You want me to show you that again? I just did this. I divided both things by 2. All right, so here's how it works. What we do is we take what we're dividing by, and we are going to take what makes that 0, meaning you're going to take the opposite of it. So instead of a positive 3, we're going to take a negative 3, and we're going to put it in a little box in the left-hand corner. So this negative 3 comes from this factor right here. It would be what you would plug in for x to make the factor a 0, okay? Or you can just remember x is a liar, take the opposite. The next thing you do is we're going to write down all of the coefficients of what we're dividing. And so what's the coefficient of x squared? There's a 1 there, right? So we're going to write down a 1. We're going to leave some space. Then we're going to write down a negative 7. And then we're going to leave some space. And then we're going to write down a 10. Leave also like a blank row right here, and then I'm going to put a bar. All right, so to start the division, what we do is we drop down the first term, which was a 1, and we put it below the line. Then we take what's below the line and we multiply by what's in the box. What's 1 times negative 3? Negative 3, we put that in the next spot. So the negative 3 goes there. Now we add. So this is instead of having to subtract, we add these together. Negative 7 plus negative 3 is negative 10. Once it's below the line, we multiply by what's in the box. What's negative 10 times negative 3? Positive 30. And 10 plus 30 is 40. Okay. But remember before how we had, like, these were x's. So we have to go back and put the x's in. I just took an x squared and I divided by a factor of x. I mean, it was x plus 3. What's going to be this term right here then? Just an x. Okay, so this is x minus 10. And the remainder is a 40. I think if I remember correctly, hold on a minute. I should do a long division one. I'll do one to compare so you believe me that they're the same thing when we're done with this next one. All right, let's try it again. So now this time I have a cubing function. It works the same way, except at the end, I'm going to have an x squared function because I'm dividing off an x. All right, so what goes in the box? Negative 2, very good. I want to also check that there are no missing terms. What I mean by that is, like on this one right here, there's an x term missing because if there is, we have to hold the spot. I'll show you that on our next one. Like once I start, I have an x cubed, x squared, x. Nope, all the terms are there. So I put the coefficients down. We have a 1, a 4, a 1, and a negative 6. Okay, here we go. We got 1. Then 1 times the negative 2 should give us negative 2. 4 plus negative 2 is positive 2. 2 times negative 2 is negative 4. 1 plus negative 4 is negative 3. Negative 3 times negative 2 is 6. Negative 6 plus 6 is 0. Okay, so now we put our polynomials in, the degrees back in again. So this was degree 3, and I just took off basically 1 degree because I was dividing by an x. So this is now going to be degree 2. So our answer would be this is 1x squared plus 2x minus 3. Okay, so let's do one more, and then I'll do synthetic division with one of the ones we did yesterday. You don't have to do that one, just to prove to you that it is the same as long division. So on this one, I have an x squared, but do you see how there's no x term in there? So I'm going to rewrite this as x squared plus 0x minus 25. When you have any missing terms kind of in the middle of the function there, you do need to hold their spot with a 0 for synthetic division to work. So that's what I'm going to put. I should have left a little more space here, but my coefficient is going to be 1, then I have a 0, and then a negative 25. What goes in the box this time? Positive 5. Now, I think most of you probably know, if you looked at this, does anybody already know what x squared minus 25 divided by x minus 5 is? Okay. 5 times 1 is 5. 0 plus 5 is 5. 5 times 5 is 25. Negative 25 plus 25 is 0. I take x squared, I reduce the power by 1, that's x plus 5 with a remainder of 0. Okay, what do you think? It's a little nicer, isn't it? Let's flip back to one of the ones we did yesterday. Let's see here. You don't have to do this. I'm going to just show you synthetic division. Just follow along, just so you see that we get the same thing as we did with long division. So if I did one of our examples from yesterday, I would put negative 2 in the box, 1, 10, and 25. So I get a 1, get a negative 2, you get an 8. Hopefully you're seeing like these similarities with the long division there. I get a negative 16, and that's my 9. So x plus 8, remainder of 9. Okay. Same thing as yesterday. If I ask you if something's a factor, what you're looking for is if there's a remainder that gives you 0. So let's pause. All right. I'm going to just put this up here. Most common question, how do you put the polynomial back in? Take the degree that you were started with and take off a degree of 1 because you were dividing by degree 1. So this should be an x squared plus 4x plus 3. Okay, we are going to do 2 and 3, but I would like to skip forward to question 5, please. And then we'll go back. What's the problem with 5? There's no squared, and also there's no x, right? So another way I could write this would be x cubed plus 0x squared plus 0x plus 27. So just wanted to talk about something where there are missing terms. Would you try that one, please? On question 6, would you please do the division a minute? So divide off x minus 1, and let's see what quadratic we get. Uh-oh, what did I do? Yikes. I messed up. Okay, let's just do a quick check-in. Did you get what I got? All right, so now we know x plus 1 is one of our factors. Because this is in degree 3, it's possible to find 3 factors. We'll talk about that a little more next week. So what I'd like us to do now is take what we have left and let's keep going. Can you think of something that multiplies to be a negative 6, but the outers and the inners add up to be a 1? Any ideas on that? So what are some things that multiply to be negative 6? Like 2s and 3s, plus or minus, and 6 and 1? Couldn't I use a 2 and a 3 if one was plus and one was minus to get a 1? I could make this x plus 3, and this would be x minus 2. And then my third factor was the one that I found from above, x plus 1. This is what we would call the complete factorization of that polynomial. All right, see if you can try question 7. And this is a skill we'll work on probably for a couple more weeks. And then I keep going. Multiplies to be 12, adds up to be negative 7, negative 4, and negative 3. And then I got to include that factor. So the complete factorization would be x plus 3. These can be in any order. X minus 4, x minus 3 would be the complete factorization of that. Okay,